Hi, hello everybody. So today I'm going to be teaching on the number based system. Now, when we talk about number based system, we're talking about systems like the decimal system which is base 10, binary system which is base 2, octal system which is base 8, and hexadecimal system. So these are the four systems, number based systems, that I will be focusing on under this topic of number based system. So but for today's video I will be focusing on the decimal. We're going to be taking it gradually, one after the other. So we'll be starting with the decimal system, and the decimal system we have the base 10. When we talk about decimal system, the decimal system is a number system where counting is done in groups of 10. We count here in groups of 10. It comprises only 10 digits. These digits that comprises the decimal systems are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the set of numbers that come together to form the decimal system, which is the base 10 system. So the first example that we have here, we are to expand this number. So we want to expand this decimal number, which is 3,875. We want to expand it. Now, when expanding numbers like these that are in base 10 or the decimal system, we are going to be picking them one after the other and then multiplying them in powers of 10. So the first one, we'll pick the first three, timesing it by 1000. How do we get this 1000? Count the number of digits behind 3. Number of digits behind 3 are just 3 digits, 1 to 3. So it means that our 0 and 1 number that we should be having should have 3 zeros, which is 1000. Picking 8, we have 2 digits after 8. So that will be 1 times 2 zeros, which is 100. So we're going to be having 1 and 2 zeros, which is 100. 8 times 100. Plus 7 times 1 digit after 7, which will make it 10. Do we have any digits after 5? No. So that will just be 5 times 1 to return back the 5. And we are adding each of these. Then the next thing we're going to be doing will now be to write these numbers, which are 1 and 0 numbers, in powers of 10 in index form. So we're going to be having it as 3 times 10 raised to power 3. How do we get this 3? How many zeros do we have? We have 3 zeros. So that'll be 10 raised to power 3. If you should calculate 10 raised to power 3, that gives you 1000. That is 10 in 3 places. This is 2 zeros. 8 times 10 raised to power 2 plus 7 times 10 raised to power 1 plus 5 times 10 raised to power 0. Why 0? When you raise a number to power of 0, it gives you 1. It gives you 1. So let's take another example. So if we have example 2, and we have a number like 6, we have 60,432. We have to expand this number. How do we expand this? So I take out my 6. How many numbers do I have after my 6? 1, 2, 3, 4. So it means that I'll be having a number of 1 and zeros, which are having the 4 zeros with it. So that'll be 6 times 1. Then I have 4 zeros. This makes it 10,000. Plus this 0 we are having here. Yes, we are going to have 0 times. How many digits do we have after the 0? That's 3. That will be 1000. 0 times 1000 plus 4 times how many numbers do we have after number 4? 2 numbers. That will be 1 and 2 zeros. Plus we have 3. How many number do we have after the 3? Is just one number. So that will be 10 plus 2 times 1 to return back our 2. Then we write these numbers, the numbers of tens, we write them in powers of 10, those 1 and 0 numbers. So we have 6 times 10 raised to power, how many zeros? 1, 2, 3, 4. So that's 4 zeros. That'll be 6 times 10 raised to power 4 plus 0 times 10 raised to power 3 plus 4 times 10 raised to power 2 plus 3 times 10 raised to power 1 plus 2 times 10 raised to the power 0. We've expanded. Remember, we have to expand these decimal numbers. Express each of the following decimal numbers in expanded notation form. That is exactly what we have done. So we've expanded each of these decimal numbers in expanded notation form. What if you're given numbers that are not just only whole numbers? Because the first example is a whole number, this one is also a whole number. So that will take us to example 3, which will be my last example. So we have 0. For example, we have a number like 0.0765. If we are to write this in expanded notation form, remember it's in base 10, it's a decimal system number. So we're still going to have this 0. Remember, if you write the values of these numbers that are in decimal, if you write their values on them, this 0 is a unit. This 0 is a unit, just like 2, just like 5. This 0 here is a unit number. So remember, our unit numbers, when we are multiplying them, when we are expanding them and multiplying them, we always multiply them by 1 and 1. So it's a unit number. If I place the values on them, this will be units. Remember, your decimal place values. So this will be units. Our decimal point, this will be tenths, this will be hundreds, this will be thousands, this will be tens of thousands. Remember, so that is why I'm saying this 0 is a unit. So we're going to be multiplying it by 1. That will be 0. So I'm expanding already. 0 times 1. 0 times 1 plus the second 0, this 0. 0 times. Now, look at the value. This value is tenths. So we are going to be multiplying it by 1 over 10 plus 7 times hundredths. 1 over 100, or hundredths, better, you call it hundreds, plus 6 times thousands, plus 5 times 10,000. Then we write we write them in index form. In index form, remember our units, when we multiply the units by 1, we always put it 10 to the power of 0. So this will now be 0 times 10 raised to the power 0 plus 0 times 10. Now, this is tenths. When we want to write it in index form, or we want to write them in powers of 10, this will be minus 1. Minus 1 plus 7 times 10. How many zeros do we have here? But we are having our 10 over. We're having it at the denominator. So it's going to be minus 2 plus 6 times 10 raised to the power minus 3 plus 5 times 10 raised to the power minus 4. So what we have done, we have simply expanded this. We've placed it in an expanded notation form, this decimal number. I hope we get the video right.